Well, in light of some of the foregoing discussion that we've had about these volumes of rotation using the disk method, we can also find volumes of revolution by rotating about axes that are something not the x-axis or the y-axis. Let's go through a typical example of that. We're told to find the volume bounded by the curve y equals 2x squared, y equals 0, and x equals 2, and rotate it about the line x equals 3. Let's see if we can picture that situation. Our curve y equals 2x squared, of course, we know to be a parabola. And so it'll come out like this, sort of, something like that. There we go. There's y equals 2x squared. And we've got the line y equals 0. So y equals 0, that's the x-axis. We've got the line x equals 2. So we go out to x equals 2, and we find where that intersects the curve right here. So this line x equals 2. And so we're going to get this area that's bounded right in here. Now this time we're asked to rotate that about the line x equals 3. So that's a vertical line right here above x equals 3. And that means we're going to take this area that we would rotate. Now, how do we get that? Well, in this case, if we're using a disk method, one thing that we're going to have to do is draw a disk to represent the volume that we're rotating. In this case, this has to be a side-to-side dy disk. Right? You see that, of course, right here. If we take this disk and we rotate this one, we're going to use a function in terms of dy. So that means we're going to have some limits for y. Well, we know that along the line y equals 0, that's going to be one of our limitations. What's the y value here? Well, of course, we're going to take 2 times 2 squared, and that's 8. So our integral, of course, is going to have a limitation along the y-axis of 8. Right? But we're going to have pi times, now we're going to have an r squared minus an r, small r squared. So what are those? What on earth in terms of dy? Well, in this case, we have to make that decision. What are we going to define? Well, in this case, my small r is going to be fixed. Right? This is my inner part. R is equal to 1, right? Because the distance from 2 to 3 is fixed. But this distance out here, which is going to form my large r function, is not fixed. So how do we find that? Well, that large r is defined in part by the line 3, x equals 3, but then we're going to have some function of x right over here. X equals some function of y to describe that. So that's where we're going to have to rewrite our original function, y equals 2x squared, as a function, x is a function of y. All right, so let's go ahead and redo that. So our function, f of y, is going to be the square root of 1/2 of y, or y over 2. Okay, so x is equal to square root of y over 2. And r, well, r is the difference between 3, the line x equals 3, and the curve x equals y over 2. So r, the large function that we need right here, is going to be the quantity 3 minus square root of y over 2. Okay, so this is going to be the function that we're going to substitute in here to find our volume. So we're going to get pi times the integral from 0 to 8 of the quantity, 3 minus the square root of y over 2 squared, minus small r squared, well, that's just 1, dy. All right, so we're going to have to modify this a bit in order to make it a little bit more usable for us. So let's go ahead and expand out 3 square root of y over 2 squared minus 1 and see what happens. Okay, so our new expression right here is going to be 8. We're going to get 9 minus 1 minus 6 square root of y over 2 plus y over 2. If you need a moment to pause and verify that for yourself, that's what we're going to use as our integral. And so now working through our integration, we're going to get pi times the following quantity, which is going to be 8y minus 2 root 2 times y to the 3 halves plus 1/4 y squared evaluated from 0 to 8. Again, take a moment, pause this video, and verify that you get the same integral. Okay, so working through by substitution, of course, substituting in 0 is going to give me 0, so I'm only concerned about this upper number right here. I'm going to get something that looks a little bit like this. It's going to be pi times 8 times 8, that's 64, minus, if I take 8 to the 3 halves times 2 root 2, well, interestingly, that gives me 64, plus 16, 1/4 of 8 squared, all minus 0, and of course, that's going to be 16 pi as the volume of the figure that I get by rotating this region about the line x equals 3.